Welcome to the Gen FAA 2024.1 Introduction tutorial video. In this high-level tutorial video, I'm going to help you through a guided step-by-step workflow on how to access an example model from the default installed example files that ships with Gen FAA, how to read results and navigate the user interface. So let's have a look at the workflows and the topics that we will cover. So we're going to open an example project. We're going to look at navigating the 3D model within Gen FAA. Then we're going to access the dynamic ribbon menus in Gen FAA, which is really important and an important concept to comprehend. We'll be looking at the input workbook overview. We will run a model analysis and then generate a design report. We'll access DesignMate, the artificial intelligence design assistant, and then we will use DesignMate to design a steel component based on the analysis results. So let's start with the first step. This is quite easy, so I would encourage you to follow with me as we progress through these steps. Now, just a quick note, in this tutorial, we are not going to learn how to input models from scratch or import models from other sources. Those will be covered in the tutorials that follow this one. For now, this is just a high-level test drive of the software so that you can get a first-hand feel of the software and acquaint yourself with some of the concepts and principles within Gen FAA. So in the first step, where we will open up a example model, make sure that you have access to your Cumulus Gate license. If not, you can access the license panel here from the ribbon that appears above the welcome screen when you open the software. So when you click on license, the license dialog will appear. And if you've already got your Cumulus Gate account set up to link to your Gen FAA licensing, you can just click on login. If not, you can head over to this link here, which will provide you with information on how to purchase a license. You could also request a trial by hitting the request trial button. This will open up your default mail application and allow you to send a mail request for a trial license issue. All right, so since I am logged in and I can see from my ribbon menu when my license expires, it means that I would be able to open up the example projects that ships with Gen FAA. Now we're going to open up the one that says Dynamo Portal Example. So if we click on the drop down here and we choose Dynamo Portal Example, we'll then be greeted with the project workflow dialog. Leave everything as is by default and click on OK. And what happens next is the Gen FAA application is processing the input data, which is an Excel format. I'll talk about that in a minute. It's running the analysis for each load case and load combination present in the project. By the way, this project doesn't have any load combinations. It's just got 3 load cases, but we'll cover that in the future. And then it will parse and read the output results back into a separate spreadsheet called the results workbook. So in the middle here, we've got our model space area. And in the next step, we're going to talk about and explain how we navigate through the 3D model. So there's a couple of concepts here. In the model space area, we've got a model toolbar at the top. There's several commands. The home button takes you to a home view. There's a magnifying glass. You can toggle orthogonal or perspective modes. There's a zoom window, a zoom in and out, a pan, a rotate, and a zoom to fit. These will all cover your kind of model orientation and zoom factors and so forth and so on. The additional toolbar buttons here at the top would be to fit the window, zoom fit in other words. You can toggle layer display for certain components in the model, whether you want to switch those on and off. So at the moment, we can actually see that now we've exposed the analytical elements behind the volumetric elements. So these were nodes and bar elements, which by default is switched off when you have performed an analysis. We've also got this dynamic selection tool here, which we'll talk about in a bit, and then some other additional selection tools. Now, you can also navigate the model by holding in the mouse wheel button and moving the mouse around. So this will allow you to do a 3D rotate. And of course, using the mouse wheel to scroll in and out allows you to scroll or zoom in and out of the model which is much easier than and faster than using the toolbars. But if you prefer to use the toolbars, then you can do that also. Now, let's have a quick look at selection. So you've got different types of selection options here, 3 of them. One is to do a pick select, to select single entities in the model. You can also choose to use a box select, which means that when you do a selection, everything that is contained within the box will be selected, or you can do a cross selection. This one in turn means that everything that touches the boundary of that selection box will be selected. Now, at any point when you've selected any element in the model, you can view its properties and the property information attached to that element. By the way, we can do the same here for nodes and bar elements, also the analytical components in the back end. So if I selected a node there and I look at the properties, I can see the node info. In addition to this, you'll notice that when you select an element, whenever you right click, it'll deselect the element and also exit the selection action that is active. You can also use the dynamic select tool, and what this does is when I select an element, it will then find that element in my input workbook and select it for me. In this case, we can see that this purlin that I selected is beam element 161. It's located here in the frame elements sheet of my input workbook. And if I look at the properties palette here, we can see that the results or the information, at least for that element, is displayed and that it corresponds with what we saw in the input workbook. Right, I think that covers the overview of the model input and the model navigation and selecting elements. We had a quick look at accessing the input workbook, but let's have a look at dynamic ribbon menus and how that is related to the model space as well as the input workbook. Now, you might have noticed as I click in different areas in the model, the ribbon changes. I'm just going to switch my volumetric model back on here and then return to our input workbook. So again, I'm selecting any cell in the input workbook and the frame elements context menu appear. I click in the model and the results ribbon appear. If I go to the nodes sheet here on my input, the ribbon changes to the contextual ribbon for nodes. Some of the panels in the contextual ribbons for the input workbook are consistent. So you'll notice doesn't matter in which sheet I am currently, I will always see the project, the data, and the model panels. But the frame elements panel is unique to the frame sheet. And for nodes, again, we've got project, data, and model, but the nodes panel is unique to this particular sheet. And the same applies to sections and materials if they are selected. Now, we're not in this tutorial, we're not going to cover entering model properties and input workbook values directly. We'll do that in the following tutorials, but in the tutorials that follow, but we are going to show you how you can edit these values. So just like in Excel, you can adjust any of these values as necessary. Some of the options will have some list options in a drop-down. And of course, if you click on the edit button at the top, if you prefer to change the values here, because sometimes it's easier, you can also do so. And when you hit apply, it will apply the updated values to a cell. The difference between apply and finish here is apply means apply the new values. Finish means just close that dialog without changing anything. Right. Now, another concept to comprehend is whenever we add elements to our input workbook, such as materials and sections, that they are dynamically linked. So in other words, if I go to frame elements sheet here, you will notice that in the drop-down, I've got the sections available that I entered in my section sheet and the materials available that I entered in my materials sheet. You could also change the sheet tabs from the contextual ribbon here at the top when you've selected any cell in the input workbook. So if I wanted to head over to project info, I can simply click on that drop-down, or I can use the arrows to move across the contextual ribbons. All right, now we also want to look at the location. So the first sheet in our input workbook is the project info. Now notice the project that we opened, the Dynamo portal example, has got an XLSX file extension. So that's right, it's an Excel format file, but GenFEA does not require Excel to be running on your machine or even to be installed in order to interpret the Excel spreadsheet. But it does mean that any project created with GenFEA could be read by any other spreadsheet software such as Microsoft Excel or Google Sheets or OpenOffice or whatever software you want to use to read Excel spreadsheets. The other really good strength about using spreadsheets in an open format for Gen FAA is that we can generate results from other external tools, such as Grasshopper from Rhino, or we can use Dynamo for Revit or Dynamo for Advanced Steel, or whatever scripts you are generating or external software that can generate CSV files or Excel spreadsheets can be used to generate input data for Gen FAA. So that is really good. It also means that we can use formulas within sheets. So you'll notice when I select the cell, so you'll notice when I select a cell and the nodes contextual ribbon appears, I've got the option to import a CSV, which will update the current sheet if we find corresponding column headers in that particular sheet. Okay, now let's just have a look at the project information. From the project information, again, the ribbon changed. If we click on the information button, we can adjust values here. So we can change the name of the project. We can click on the button to adjust the location. And this is using a dynamic Bing Maps dialog, which allows us to double click on any location or to enter the address and search for it to change the project location. We can also set the company information, the designer, the design date, and the units that we want to use in our project. Now, I'm going to explain why this is important, but let's first update the analysis in the model since I've made some changes. So to update the analysis and rerun the analysis, make sure the parse, analyze, and display options are checked in the contextual ribbon menu of any of the input workbook contextual ribbons, and then simply click on the top part of the update button. When we do that, it is going to rerun the model, rebuild the analytical backend, and then perform the analysis for each load case and then superimpose the results back into the model. Now, that covers the input workbook for the purposes of this series of the introduction tutorial. Now, I've already explained the concepts of the input workbook here. So we saw that we can use standard spreadsheet formats, we dynamically link cells, and that we can either enter values directly in sheets or we can use the contextual edit ribbons to do that. One thing I forgot to show you is that you can also dynamically find elements in the model. So if I head over to my frame elements and I select any cell, all I need to do is click on show and it will highlight and zoom to the selected element. I already showed you before, let's just clear the selection, that if my dynamic selection is switched on, I can do the opposite or the other direction again by selecting an element, and then it will then select the appropriate row in my input workbook. Now, since we are in the results output, we can see that our analysis status is green. We can also, when I click on the model space, select to switch on deflection or axial forces or moments in the model. We can view support reactions. Notice when I click on support reactions, additional buttons appear for the X, Y, and Z directions respectively, and we can toggle those and switch those on so that we can visualize those results. We can also choose to hide any of the palettes at any point to auto hide them, or we can simply drag them and place them on a second screen and resize them to provide us with more screen real estate. If we want to place them back, all we do is drag them onto the dock controls and resize them or hide them if we need to do so. From the Model Ribbon tab, you can switch on elements such as the supports, and this is not support reactions, this is showing us the support type. So in this case, all of these are fixed. We can switch the symbol size here. We can switch on the labels for all of the elements in the model to be able to identify node and beam elements numbers. And if we wish, we could also display loads. Before I display the loads, let's change the current load case to load case 2. Since load case 1 has only got a single point load, I know because I put it there. And if I click on show loads here, we can see the loads, the linear beam loads now displayed on the beams. And again, we can adjust the symbol size here to scale that up and down as required. Okay, I think that's fairly self-explanatory. So we'll move on to the next step. Let's jump through this one. We've already run the analysis on this model, and we've looked at the output. Let's access the design report. So this is one of the reasons why we enter the project information here in the project info sheet, because once we've run the analysis and we head to the workspace, we click on the design report button, and from here, if we choose generate and leave all the options as per the default and simply click OK, it's going to start running through the model, and it's going to generate a design report output based on our information. So we see the title, we see a hero graphic here of the model, we can see the location with the address plotted below that. We see the model summary, and then the graphical and tabular outputs depending on what we've selected as the options in our report, design report output. Okay, so that's the one reason. The other very important reason for the project location is for DesignMate. So to access DesignMate, before you can start using it, there's a few things that you need to do. So first of all, from the workspace, you're going to click on DesignMate. In my case, I've already set up my account. So if I head over to my models option, you can see my API key has already been entered. So it means I've got access to the DesignMate features, which is built on top of the OpenAI GPT-4 API. Now, if you want to access the same, you need to go to platform.openai.com/API keys. This assumes that you already have an OpenAI account. If you don't have one, simply go to this URL, exactly like it's typed here, platform.openai.com/API-keys. You can register a new account, and I would highly recommend that you create a Plus account. It costs $20 per month, which is not a lot. Or you can access a team account. Both of these are supported. If you do not opt for the Plus plan, it means you won't have access to GPT-4. Now, we do support GPT 3.5 Turbo, but it is not as powerful and accurate as GPT-4, obviously. So again, I highly recommend the GPT-4 option. Okay, once this is done, you'll be able to access the DesignMate features. Now, let's have a look at our first design, which is going to be the next step here in our workflow, and also the last one. So to create the design, we are first going to prime the LLM, in other words, DesignMate. So we're going to make sure the persona that's selected is DesignMate. We're going to choose the design group here, columns, and we're going to click Prime LLM. When I do that, it's sending critical information and a summary of the project to DesignMate, and DesignMate will respond by saying that, okay, it's now processed information, it knows the location, and now we can start asking questions about design. Now we can either start entering our questions here manually. We could say, could you please design a rectangular footing, with X and Y parameters, or we can select from the design templates that is preset up here to start doing our design. And here is an example of a design footing template. Now, we don't have to use the templates that ships with the software. You can also use the template editor to create either your own template files or to open an existing template file, and you can then, through doing this, create your own design components. So that really means that we have unlimited options for the elements and components that DesignMate can design. Now, we want to leverage off of the study model results. So if I choose base plate design, I have to enter the column section size, I have to enter the design code, I have to enter the steel grade and the actual forces and moments and so forth. But we already have that in the model. So instead of doing a generic design from scratch, we are going to say, let's do a base plate design from study. So now we've got much less options we need to enter because the information is already present in the analysis results. So we are simply going to enter a couple of parameters here for the concrete strength, the anchor bolt size, the anchor bolt grade, the spacing. We can either give it a numerical value or we can just say determine it for us. It doesn't matter what you type in here. This is natural language inputs because we're working with an AI system, so you can be creative. And you can even leave them blank if you want. And when I click on send, it's going to send that information to the AI engine, and it's going to analyze the results, and it's going to start producing results for you. Now, while that is happening, I would like to show you something. If we look at the usage for today, you can see that we're currently on 41 cents. And I can tell you I've already run several design options today, but you can see for 23 January, which is today's date, we've used a total of 41 cents. And let's have a look at that token usage once DesignMate is completed and we've completed with this whole design process. And I can already tell you it's going to be less than 10 cents. So it's extremely cheap and very cost effective, and it's not going to take a lot out of your pocket to be able to run these. So while this is running, let's talk about some of the other design components. Now, as we mentioned before, you're able to use any of these templates out of the box, but you can also use the template editor to create your own templates based on any kind of design, distribute them in your company or amongst your team, and they will have access to them and use those same components. And this just helps you to fast track the process of entering information in a formalized, standardized way that you enter back into DesignMate. There's also some additional commands in the back end of these templates instructing DesignMate on how to respond so that we can generate and present mathematical formulas, as you see here on the screen, correctly so that they render like proper maths. We're using something called latex formatting for the math output, and DesignMate is smart enough to know that it should produce results that is compatible with this. So we can see here that it's now run through a design check and it's starting to give us some results, and it's telling us what the base plate dimension should be with the thickness, with the bolts and the bolt spacing. It's telling us what design standards it used, or that it was using, and how it has derived these results. And it's as simple as that. You can also use DesignMate for many other tools. If I want to create a new conversation, I click on the new button and we can either choose the DesignMate persona, or if we want to use the internal C# scripting engine within GenFEA, we can ask DesignMate to create some scripts for us to automate our model generation. And I'll show you an example. In this one, I'm just accessing my chat history. In this one, in the past, I asked GenFEA to create a C# GenFEA script for a basic square tower with dimensions X and Y, and it produced this output for me, right? So from here, I can copy this code, and if I go to my C# scripting workspace, I'll be able to paste that into the scripting engine and run it, and it will generate that structure for me. So if I go here, paste it in there, I can simply run this and it's going to create the structure for me, which is really exciting because it means that we can not only use DesignMate for designs, but also for model generation. You can further iterate through responses. So once DesignMate has responded to something, you can come with a follow-up question. You can say, fine, thank you, but can we iterate further or optimize this design, or tie this into the next component? So you can enter any text you like in the text area below. You can even record your voice, and that will be automatically converted from speech to text, or you can attach external files as additional input information for DesignMate. In any case, that concludes the introduction tutorial. In the tutorials that follow this one, we'll look at in-depth steps and workflows on how to create models from scratch by entering values directly into the input workbooks. And we'll also look at importing from various sources, from externally created Excel files, importing 3D DWGs and DXF files, and importing from other structural analysis software. Thank you. See you soon. Goodbye.